Algebra 1, Module 2, Algebraic Models, Lesson 2.3, Solving for Variable. So we have this warm-up. If you haven't done so already, please try this on your own. Just a little bit of hints, I guess. But before you do, let me give you a little bit of a background information on this expression, simple interest rate. Because there is a difference between a simple interest rate and a compound interest rate. So as a reminder, so for example, let's say if you have initial deposit amount or the principal amount, P is 100, and simple interest rate is 6%, then the interest will be the interest rate R times the principal amount. It will be 0.06 times 100, which is $6. So this amount is what you would have total. That's principal plus the interest and 106. Well, that's very well nice, but what's different about math class is that we have to be able to find a pattern, right? Not just solve a single problem of a single case. So let's generalize that a little bit, shall we? So the total amount of money that we had was the principal amount with it plus the interest, and interest is the interest rate times P. If that's the case, couldn't you factor out the P and end up with this right here? Right? So it's principal amount times 1 plus R. If the R is 6%, all this is saying is that we're adding that to 1. So 0.06 plus 1 is 1.06. So the money that you're going to get at the end of the year is 1.06 P. So if you have 10%, that'll be 1 plus 0.1, 1.1 P, and so on and so forth. You could use the same idea, actually, similar idea. Instead of having, think of it as interest, simple interest rate, you could think of it as a tax. What if your tax was 6%, right? Well, the calculation is exactly the same. So in Santa Clara, I think it's 9.25%, I think. Well, it's around there somewhere. So let's say 10%, right? So if you buy 10%, if you buy a $100 radio, let's say, right? Guess what? You're going to pay $110 because if you're adding the interest rate over here, that's 0.1. This turns out to be 1.1p. All right? So whatever the price is, you multiply by 1.1, and you get the general idea of how much you will pay after tax in Santa Clara. Okay. All right, guys. So be that as it may, try this on your own. Pause the video. Okay, guys. So this is what we did in class. Okay. So we got a bunch of information. So we have Stacy, Oliver, and Javesh, and they're putting money into the bank. Sandbank, as it appears, at 6% per year. So Stacy puts $550 more than Javesh, and Oliver puts 2 times as much as Javesh. And a year later, there's a condition that happens. Let's address that a little later. So, what's going on? Stacy puts $550 more than Javesh, but how much is Javesh paying? We don't know, so let's call it J because his name is Javesh. Stacy puts $550 more than that, so whatever the J puts in, which is J plus 550, that is what Stacy's putting in. Okay, and Olivia is putting in what? Twice as much as Javesh, so that makes it 2J. Now, a year later, because they're talking about stuff that happens a year from now, I think I want to know the expression for the money they have a year from now, right? And as we learned over here, when they're paying 6% for 1 year, whether it be simple or compound, in this case, is 1.06. You multiply whatever the value is times 1.06, right? That's what it says here, 6% in 1 year. So that's magenta. Okay, let's do that. So Javesh will have whatever he has times 1.06. 1.06, whatever he has. What does he have? J. Oliver. What does he have? Yeah, 1.06 times 2J. Stacy. How much does Stacy have? That's 1.06 times J plus 550. That's it. Now, here comes the algebra, right? The typical setup in algebra. Okay. Oh, by the way, this is like okay, let's move on. So the fact that it's after a year tells me that I should use the values from here, this expressions from this column. Yeah. According to this, Stacy has twice. Ooh, let's write that down. I'm gonna use black, not gray. Stacy is S. Okay, you know what? Stacy is equal to twice the sum of. You add something. What are you adding? 212 plus Oliver. But here's the problem though. Stacy has two things related to it. Which one do you use? Same thing with Oliver. The two expressions. Because it is after 1 year, we use from here. Overlapping with Stacy, intersection is this one, isn't it? Right, so that's what we copy down for Stacy. 1.06 J plus 550. Twice 212 plus Oliver is this one here, right? 1.06 2J. Okay, now it's your job to simplify this expression. And you can pause this video at any time and try work on this on your own. If you distribute the 2, that's 424 plus 2 times 2 is 4 times 1.06. Isn't that 4.224? I think so, isn't it? 1.06 times 4, that's 24. Yeah, 4.24J. That's 1.06J plus 550. And then you go from there, right? Why don't you go ahead and solve for J? But here's the thing though. They're asking how much does each person initially put down, so we gotta find out what these three are once you find the J. And then, who has the most money after a year? Who has the least? Well, whoever had it the most to begin with will end up with the most because they grow at relatively the same amount, so the relationship would not change, right? All right, why don't you go ahead and try to fill out the rest of the information. Okay, so this is what I got. I solved for it, and I found that J is equal to 50 when you go to the calculation. When you put that in the calculator, it gives you exactly $50. So Javesh has $50. Twice the J, 50 is 100. And 550 more than Javesh is 600. Right? So that's the initial amount. So these three numbers answers these question right here. So who had the most? Well, you could multiply 1.06 to this amount, give 636, and the rest is 106 and 53. So Stacy has the most, Javesh has the least. Okie dokie. All right, guys. Let's move on to the actual lesson. Okay. Here, the literal equation here are equations that contain two or more variables, and there are many literal equations in the form of math and science and engineering formula. So one of the things that really stand out is formula for density, right here. So density is, you know how we might say gold is heavier than styrofoam? That's not true. Because we don't have very important information. Is that if you have like tiny amount of gold, you could have a gram of gold, right? And you could have a ton of styrofoam. It depends on the size. But I think when people say something's heavier, I think they're implying that given the same size, right? So when you hold the size constant, gold is definitely heavier than styrofoam. Gold is heavier than aluminum. Gold is heavier than a lot of things, actually, right? Because gold has what they call higher density, right here. So higher density, the word density is comparing a mass, right? That's measured in kilogram, right? And the mass uh, is different from weight in that weight takes into consideration of the gravity. So I would say your school book will weigh differently in Earth versus Moon. If I'm not mistaken, Moon is 1/6 that of the gravity. It's been a while since I've taken physics, right? But but the mass does not change. It does not change from Earth to Moon, right? So that's measured in kilograms. Okay. All right, guys. So let's talk about this. The actual question. So let's pull back from this general idea of science. So the density, by definition, is the mass divided by volume, right? Higher density means something quote unquote weighs more on Earth given the same size. Okay, so lead has a density of 11,340 kilograms per meter cubed. So basically, this cube of size of 1 meter, 1 meter, 1 meter, which is approximately 3 feet in each size. It's actually 3.3, I think, feet on each dimension. That's a pretty big box, but it's probably smaller than a car, right? Average car weighs about 2,000 something kilograms. That is very heavy. So lead has a high, very, very high density, right? Plastic foam, on the other hand, has a very low density. Given the same size, is 75 kilograms. That's like the weight of the average, I guess, 18-year-old, I guess, right? That's about 165 pounds, right? Ish. All right, so we have those things that. So how do I do this? Using the formula, we're going to figure out the rest, okay? So density depends on the mass and the volume. In this case, a sinker of a fishing line mixed with lead has a volume of this. What is the mass of the sinker? Okay, first of all. They're asking a question. What is the mass of the sinker, right? How would you do this? Okay. So we're looking for the mass. So given the information, D is equal to mv, let's solve for m. How do I do that? If you said multiply v to both sides, you're absolutely right. So therefore m is equal to dv. But what is d? The density for the lead is 11,340 kilograms per meter cubed, and the volume is 0.00015 meter cubed. The meter cubes cancel, so now we end up multiplying these two numbers, and the weight is kilogram. Just remember that 1 kilogram is about 2.2 pounds. Okay. Now in the second case, I'll show you the answer in a second, guys. Okay. In the second case, the design for the life preserver requires only 0.3 kilograms. So, that's mass, right? Because kilogram is a mass, that's m. So it's asking you to find the volume, v, using this information. So d is equal to mv. When you cross multiply, dv is equal to m. So v therefore is m over d. Okay. Another way to think about this is that you could think of this question like d over 1 mv, right? So you could actually swap places diagonally, okay? Which will in the end will give you that expression. So we could talk more about that later, okay? So if the v is equal to m divided by d is equal to, the mass is a 0.3 kilogram divided by the density, which is 75 kilogram per meter cube. That turns out to be, because the volume is supposed to be in terms of meter cube, right? You gotta divide that number, and what is it? Okay, here you go. Here's the answer. Same work here. So for the sinker, that's actually 0.1701 kilograms, or about 170 grams. And then for the volume over here, that comes out to 0.004 cubic meter. Okay, sounds good. All right, let's do the other set of problems, shall we? Coming back to this. So this one gives you the I equal to PRT. That's the formula for the simple interest rate, right? The only difference from what I did from earlier, they just added a T. How many years do you do it, right? Yeah. So that's the amount of money that the interest that you earn on a given principal. P here stands for the principal amount. I represents the interest that you earn, total interest. R is the interest rate, and T is how many years, right? T is the time in years, okay? So in one of the periods, we did A, the other period we did B, okay? If you'd like to try this on your own, because you weren't in class for whatever reason, try this on your own first. It's probably a good idea. Okay. A. Find the number of years you use to calculate blah, 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 blah. Oh, it's a solve for T. Let's do that first, shall we? I is equal to PRT. If you're solving for T, we need to get rid of the PR, because it's PR times T. We divide T to both sides, right? If you do that, they cancel. So that implies that the T is I divided by PR. Isn't that right? All right, guys. If that's the case, what is my capital I? That's the interest that you earn, which is $600. And the P is $1,000. And the rate is 5%. So you don't write down 5%. You have to convert that to a decimal. And that is 5 out of 100, which is 5 cents, right? Right. So you could think of percent as cent of a dollar. If it's 25 cents, in decimal is 25 cents is right. 0.25 $0.25. Right. That's how you could do that. And you could run this number in the calculator and get your answer there. Okay. Now part B, determine the interest rate, blah, 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 of $200 in loan. That's the P, isn't it? Oh yeah, that's the P. Okay, so that's a P. So 4 years, that's a T. Interest, that's I, right? And I guess they're asking us to find R, the interest rate. Okay. If you have I is equal to PRT, we're trying to get rid of the P and the T, right? Right, we divide by PT. Like this. So the R, therefore, is equal to I divided by capital P times T. So what is I? 640. P is 2,000. And T is 4 years. And that will give you the rate in decimal. So you would have to convert that into percent. Okay, when I did that in class, this is what we got. So we got 12 years over here. So this is what I should have done in class. But during the class, I guess I forgot to read this part. So I just went with the I equal to PRT, plug in the value, then solve for the T, right? The only reason that would not be acceptable is simply because of this direction. If I didn't have that, this is perfectly legal. But because I had this, you have to solve for T first, this one, and then plug in the values, okay? So that took 12 years, guys. So given $1,000 at 5%, to earn $600, it will take you 12 years in a simple interest rate. Now, Part B, same thing. We solve for the R and plug the values in. 0.08, which is equal to, so that's like $0.08, right? So that's like 8 cents or 8%. All right, guys. So that is it. So why don't you try your turn, see, and see if you could get this. All right. I presume that you paused the video already. If not, please do so. Here are the answers. See that I spent quite a bit of time doing the other problems. I'm just gonna leave this be. I don't want to have the videos go too long. Anyways, if you have questions about any one of these and would like me to explain to you in person at length, please come to the tutorial. Otherwise, I shall see you in the next video or in the classroom. Okay, have a good night.